Okay, today we will move on to talk about chapter 11. So let's take a look of this one here. Let me see if I can enlarge a little bit. And I hope you understand that the differences between interface and a class, right? So the interface means that we do not implement any of the method. Interface is just list of the common methods that the class that implements it will have to write the code in it. So important interfaces here is a list, capital S, look here. So interface is basically a class, but we specifically call them interface is because they are specific classes. All right, those classes allow us to have a common methods, common behaviors. So important one here, again, it's a list. And array list, it's actually implement list. Okay, so array list is implement list. And later we'll talk about linked list here. It's also implement list. So what that really means that the common method like add, set, remove, size, index of, etc., is all those methods. Array list has to implement it, and linked list has to implement it. And today in this chapter, so we talk about array list in chapter 10. We will talk about linked list later. And in this chapter, and we will focus on another interface, set. All right. The set, the differences between set and list is that list set means that you don't have any repeat. Okay. So for example, if we have a list of GPA and then the list, if this is a list, that means we can have 2 4.0 in it. Okay, but for the set, you cannot have 2.0 in it, and there's only one 4.0 in it. So the set means it's a collection that doesn't have any repeat. It's a unique connections. Okay, so that's a set. And the set can be ordered or sorted. Okay, you can sort them based on maybe the values and maybe alphabetic order. All right, so there are two classes that implement the interface set. One is hash set that we're going to talk about today. Another is called tree set, and we will talk about today too. And the differences between those two is that the tree set, it's a sorted, and hash set, it's not. Then you'll ask why we have a two, okay? Why we want not always just want to use the tree set, you know, then by the time we have the tree set, everything's already sorted. So there is a pros and cons about which one you choose here. You need to think about always that the speed. Okay, one of the things we study algorithms here is that speed is extremely important. How fast you can find the things, you can add the things, you can remove the things, you can manipulate the collections. It's extremely important. Okay, so we have two kind of set classes. Okay, so hash set and tree set. Again, we will talk about it. And also in this chapter, we'll study map. Okay, again, for map, we also have two. Okay, we also have hash map and tree map. All right. And in this chapter, we will talk about iterator. Okay, we'll talk about iterator. And so, the iterator, it's an interface. And this iterator interface will be used to kind of walk through, kind of like the for loop, the eyes, the contours. So we'll talk about that. So this chapter is actually covered the iterator, the map, and the set. Okay. So let's go over. You understand, right? We're going to study set, map, and iterator. More data structures. So let's see, what's the problem we can have here? This is the question here. Okay, so let's talk about the set. Again, the set is collection. Okay, so when we talk about collection, it means that it's a bunch of data there. Okay, now if I gave you a bunch of data, of course, the old way is that you can put them into an array or into an array list, or now we have more data structure to handle this data. Okay, because sometimes we want to have a unique value, which means there's no duplicate in the collection. So, and then the standard method like add, remove, okay, contains or index of. There is not really index of because it's not ordered. Okay, we don't really order them. But the tree set maybe. So we don't really think they have any index. All right, we just add them. Okay, we just add them into a set. Okay. And so how can we use the set is we need to include a Java tail in our code. And again, we can choose to use the class hash set, or we can choose to use the tree set. What's the differences? It's on here. This is very, very important about how fast, okay, something can, some algorithm can be useful for. So hash set, they are using hash table. So we're going to talk about what that means, the hash table. So basically, you can think about hash table is kind of an index, all right? And then we're using some hash functions to generate an index. And then we'll just go ahead and then put this values into that position, okay? So the hash set, the reason we're using hash set because they are very fast. So every time when we say capital O and 1, so that means it's a constant. Capital O is a notation. It's a big O notation to indicate how fast we can implement or this operation runs. Okay, so the capital O1 means that it doesn't matter how big your data set is, and it's can always running not depending on the size of the set. Okay, and it runs very fast. For tree set, and that's more complicated. Okay, it's actually later on we're gonna study what is the binary search tree, and which is another more complicated data structure we'll learn. So behind the surface, the implementation it's using the binary search tree. And the reason it's pretty fast, because then we'll talk about everything. If we have a log of the sides, then that's pretty fast too. Think about the log means here, log n. So let's say if your size is 2 to the power of, say, 32, and that's a huge already, and that's probably in the minutes of the number of data in your set. But then how fast the log to the 2 to the power of 32? It's actually 32. So that's pretty fast. Okay, so from now on, we really need to think about log only. We need to, this is also tell us why we're using different data structure. The choosing of the data structure, it's very important, because it really helps the computer to operate very fast for finding things, for add things, or for remove things. So we store the data when we have a set of data, and we need to have some basic operation into it, right? We should be able to add them, we should be able to find a useful information, and we should be able to clean up. And so those operations probably going to happen lots of times. And so the algorithms to run on those data, it's important, how fast it is. And so choosing the right data structure now, it's become a critical. And that's exactly the reason that you study this course, is that when you study the basic Java, you just learn the basic concept and principles. And this one is really put the language into use. So if you want to find any jobs as a software engineer, and you have to learn data structure and algorithms, because every time when you want to write an applications, and most likely your application will be, depend on the data, and lots of data in those days. So which one you're going to save, which data structure you're going to choose to put the data in, to save into your computers, and that will impact how fast your application runs. Okay, so the big notation here, we don't really officially kind of study it, but I want you to really get to know it. The big O notation that just indicate roughly how fast this algorithm will run. And so if we have a big O1, and that's the fastest one, and then if we have a big O log n, and that's pretty fast. Then the next one is a big O n, which is linear, that's already pretty slow. Then if we have a big O and log n, and that's also slow. But anything, if we go to big O n squared, that's pretty much useless in real world. Okay, so get used to the big O notation. Now, when we have a data structure here set, we really need to know how to use them. Okay, and first of all, we need to know how to create a one. Okay, so on the left here, you can see we have a list, which is an interface. And then we'll say what kind of a list. So we say this is a string. And then we give a lowercase list that indicate this is the object of a set. All right. And so of array list, sorry. And then on the right here, we actually can say new array list. So on the right hand side, we must give a specific class name. This is a list. And then on the set, it's very similar. Okay, so again, we have a set, which is an interface, and then we can have an integer, or we can have a string. So then lowercase set is the object of a set. And then on the right hand side, we need to see that we need to give a class name. So the set is a tree set. It's an integer tree set. Okay, and then we have parentheses here. And this set, it's empty. All right. And the second one is a string. Set 2 is a string. And we can also passing an object into it. For example, list. If this list, we already add something in here, and then we can pass the list into a hash set, or if we want, we can pass to the tree set. And so this is how to construct. This is how to construct a set. You can tell it's very similar here to the array list, right? And also, if we look the method here, we have an add, and we have a tens. We don't have an index of because the set doesn't really have an index. And we have a remove, and we can know what's the size. And we can also check to see if the set is empty. And we can have a method toString, therefore we can print them out. And so the way that it's standard print out, just kind of like the list also. So this is, you need to remember the most important set method that we're going to be used again and again and again. All right. Okay. Now, set is actually a very important mathematic concept, right? So from the math standpoint of view, the union, so if we have a set A and set B, and the union of A union B is everything in both, right? In both sets. And we can also have intersection of two sets, and that's the element in both sets. And we can also have a difference, A minus B. It's every element in A, but not in B. So for a specific set operations, we can also have a method. For example, we can do add all. And so you give me all the connections, you give me set A, you give me, set B, and they will do a union operation. Okay. And then we can also compare to see if the two sets contain the same element. The set can go have a method of iterator. This is the iterator we talk about, and we'll show you later on how can we use the iterator and to return an object. Okay. And we can remove them, and we can also remove the element not found in the given connection. So this is the A minus, the differences operations. Okay. All right. And for the union operation, it contains all, because you want to see if this one is also contains the other set B, then you using contains all. And we can also change the set to arrays. Okay. All right, so this is more specific about the set operations. Again, there is, if we're using a hash set, the order of the set is really random, okay? and because it really depends on the hash code that being generated. But if we're using the tree set, as long as the string has an order, and then we'll order them into their what they call the nature sorted order. So if you want to use the tree set, a class, that class has to be ordered, has to be able to know, what's the order of the set is. All right. Okay, I will pause here and let's just see. I will pause here and let's go to, we'll talk about the examples soon, okay? I'm going here. And let's go to the Codiva. All right. And I am in data structure, so I create data structure and algorithms. And I am in, I'm gonna go into chapter 10. All right. So let me close this one here and I will say new. And I can change chapter 10 to 11. So it will create a new directory called chapter 11. And so I will create, I'll call this set methods. Okay, let's see what happens here. All right, let's see how we can use some of the sets methods here. So we'll do create. All right, so the first thing here, I want to change this to public, and I want to import java.util because the set is in the utility package or library. All right, we can change this one later, right? So let's see how can we create a set. So we'll say set, and we can create a string. And so let's call this names equal to new. Now we can say hash set. So this is a class string. Okay. And so if we do this way here, and that is just empty set, right? And so we can print names, and you will see maybe nothing there. Okay. Now, how can we add to it? We'll say names, add, okay, and then we'll give the name, say Claire, right? And we can add the names, and we'll call John. Right. And so let's just see if we add the names and John again. And then we'll print out and see what happened here. Okay. So you can see there is nothing indicate that the code has any issues. So I just assume everything is okay. Otherwise, say if I missing semicolon, there is a red cross here. Hey, there's something's wrong, and sometimes they give me a good indication to say I'm expecting a semicolon here. All right. Okay, cool. So when we click on the run here, it will do compile this into the bytecode and then further runs the generate the code and run to present print screen. So you can see that it's not ordered, right? I have entered John twice, but it only showed up once. All right, and it's not really ordered. Okay, it's not ordered. Okay, so and that's a set. Now this is very useful, particularly. So let's say if I give you a file and you want to find out what's the how many totally unique words in a file, then that will be very easy to do, right? And so this is hash set, and we can continue, right? We can continue. You can testing. You can do like we can do a different ones. So we can do set, all right, and let's do integer, or we can do double. Okay, and we'll say GPA equals to new, and this time let's do tree set double. So we can go to do, create the add to. So again, we can say GPA dot add 3.5, okay, and we'll say GPA dot I don't know, 3.1, and GPA dot add 4.0. Whoops. On GPA dot add, right? Okay, so we can add quite a lot. Okay, so we can repeat, right? So we add again, so we add, but what you think is gonna show up? And we can copy this one and paste. So I have to say this is cost to string, right? So what you think we're gonna show up? You guys have an answer for me? In order. In no order, in all order. Yes, when you talk about the tree set, it will in order. Okay, so what it will print out? What you think it will print out? Okay, tell me what's the solution. Come on, tell me. If I give you the code, enter in the chat, what will print out? So GPA, what will the GPA print out? Everyone, give me the answer there. So here is what I enter, what I add, and then I want to print. Oh, I'm sorry, not names, GPA. So when I type GPA, tell me in the chat. Okay, that's good. That's even better. Muhammad, no. Okay, so I think, yeah, Benjamin's solution, it's good. You just type in the answer. Sarah's answer is good. And Declan's answer is good. Yeah, good. Do you guys following me and type in Codiva? You should do that. So if I run this one here, and yes, we'll have a square bracket. And so we have a comma into it, and then we will have the ordered here. All right. So this is, again, as I said, the most important one here is we'll do add. You can also do remove if you want to. You can find the size. We're using the toString all the time to print things out, right? Okay. Now let's do some of the set operations. Okay, and we can have connections here. So let's do some of the set operations. All right. So we can slice them. So how many sets we have? We have names and we have a GPA, right? So let's create. Which do you think? So if we do system.out.println, let's go here, content, add all. It adds all element from the given connection to the set. So if I do here, if I do print names dot add all GPA, what do you think? Oh, did I print something's not right? Add all cannot be applied to a given. Oh, I need to do string. I'm so sorry. You're right. Okay. So what I'm gonna do here is let's create another one. I'm gonna say set and string. And I'm gonna create another one called students. Okay. Equal to new. And in this one, do hash set string and empty here. And here, I'm gonna just do, I'll copy, say, oops, what I'm doing here. And then let's do students.add, and I can do John here again. And I'll have students.add. I'm going to type one of your names here, Black. All right. Okay. And then let's do names.add students. Oh, come on. All right. Is that better? Names.add all students. Here we go. So tell me what's this printout? Here's the question. What is the printout? Okay. What is a printout here? You see my screen here, right? So I have names, okay, and I have another set and I do at all. And what is the printout? Oh, too fast? You think this is too fast? I will pause here and let you practice. Okay. Good job, Mohammed. Got it? Yes. Everyone agree? So let's run this one. Oh, it's true. Okay, that might they let you do it. It says true. Okay, I print the wrong thing. Okay, I print the wrong thing. I got it. So I should do this way, X and V. So names, semicolon, and I should print the names, okay? Because the names changed. So now if I run, so it's because the order, it really doesn't matter. It's the hash set, so you can see that it's not in the order, doesn't really matter, okay? It could be random. So yeah, mine says true. Now you got it. So let me go back. That's why we need more exercise, okay? Don't be afraid to make mistakes here, as I just did. This one here, okay, it's return true if the operation runs, right? So it returns true if the operation runs correctly, right? But then after the operation, we changed the names. The set names has been changed. So I shouldn't print this operation. I should print the result of the operation. That means I should print the names. So when I print the names, it actually shows me how the things they did, the union operation. So this set has clear John and this set has John black. So the union is that every element in both sets. And so that's clear John and then black. Okay, I will stop the recording